Hello, and welcome back to another coding session with Mr. Jacob. Today I thought we could do something a little bit festive and use more or less maybe the PixelLoop engine and create something in the terminal again. Like, for example, a tool to maybe display an animated GIF pixel sequence in our terminal. Something like maybe the one that I already downloaded here, come on, which is maybe this one. Let's make this a little bit bigger, maybe something like that, like a center which with a little bit movement there, and we could write something from scratch to display this as an animation in the terminal. And maybe I got some more GIFs here as an example that we could actually try out. So I think we might just start. As you can see, I've just have this empty folder here, and I thought we go ahead and do this from scratch again. So we do a cargo init there, and then we can go into our editor and let's get right into it. So we have our main RS here. But first of all, I guess we need some little dependencies at least. So let's go to the cargo toml and let's add, first of all, our PixelLoop engine. We don't really care about the version. Let's just take the newest one, or let's take the one, the 0.10 version. And let's disable the default features exactly, and let's set our feature set to cross-term. Because I guess we don't need the window rendering system here because we want to create something in our terminal. We could, of course, use it later on to render into a window as well if we like to. We can change this, but this should actually make compiling cycles a little bit faster. So the next thing that we need is something to actually open up the GIFs, I think. So image, the image crate, the image RS crate can do that. I've done that some time ago. It's quite some time ago actually, but we will see. I guess we will have to take a look in the documentation there a little bit. So first of all, let's do some basic initialization. So what we need here is, I guess, we need to somehow get our environment. So the easiest way, not an environment, but the command line arguments. So I guess we can simply take one argument, which takes the GIF. That would be the easiest way to do it, I guess. So maybe let's not const. Done a little bit too much JavaScript in the last time. But let's see. It is std_env, isn't it? Args, I guess. And we might collect that just into a vector here, and maybe we can give it that we want a vector of strings. Is that possible? Seems to work. Okay, so now we should have arguments. So let's quickly check if argslen is less than 1, I guess. Then we simply... do we panic? I guess we can panic here. We can create more robust error handling in the end there. So usage would be something like the executable name plus the GIF, the animated GIF or GIF. Is it GIF or GIF? I'm not sure. I think the creator once said that it is actually called GIF. However, I've always called it GIF. There is something like, I don't know how it is actually called. Let's see. You can actually get the application name, or executable name Rust. There is a function to get the executable name. Executable name. Yeah, I should write executable name. Current ASCII, exactly, and it's in std_env as well. Okay. So std_env current ASCII, and this gives us a result. So let's quickly change that to actually return a result here, usually, so that we can shortcut out of this thing. However, I guess maybe we should import. What did I just do? Okay, I have no idea. I wanted to change to the cargo toml. Okay, perfect. So now let's just add anyhow here as a dependency, and let's go back to our main RS. And now we should be able to import that. So use anyhow result. And that should make things a little bit better here. And what's its problem here? PathBuff doesn't implement the display. Oh, that's actually interesting. Can we do something like to str? Is this possible? It is possible, but it is an option, so we do an unwrap here. Okay, so now we should be able to do that, and otherwise we should be able to should get the path, I guess. So arcs 0. We should actually be able to access it like that, shouldn't we? Because, well, the type string does not implement copy. I see. So, can we clone it? Okay. So now we should have the path, and we could do something like, just for debugging purposes, output showing dot path name. Let's call it path name. Okay, so now we have something like the GIFs. We could try and open it, and I guess first things first, I would assume that we need some sort of reader for it. So let's get a new buffered reader, and let's do a file open here on the path name. And I guess we will need to import this one, and no, not make it smaller, but import this one as well and fix this typo here. And I guess this might fail actually, and now we should have a reader. Okay, and now let's take a quick look how we actually open docs rs/image. Let's see, let's make this a little bit bigger. And let's see, do we have something like GIF a GIF decoder? Wrapper structure around cursor, GIF decoder. Okay, how does this thing actually work? New, a new with a reader gives us an image result with a GIF decoder. Creates a new decoder that decodes the input stream R. Okay, and then we, consume the decoder producing a series of frames. That kind of looks something like we want, and we can... Okay, so first of all, we need a GIF decoder. Okay, I guess we can create this one then. Let's call it decoder equals GIF decoder new, and we put in the reader there, and we need to import the GIF decoder, of course. And was this able to fail? It's an image result, so I guess that is an error actually. So can we unwrap that directly? It seems so. So now we have a decoder, and we need to do something with the frames there. So I guess we need to kind of convert them into something that our... By the way, I have the I have the correct correct cup here. Okay, so I guess we need to decode that into the different frames. So let's see. We need to decode that and store that, I guess, ideally as canvases for our image loop. Which, by the way, we haven't fixed yet. Maybe I will have fixed that when the video is out. However, currently it is not fixed. We will need image load here, which is a little bit of confusing because our in-memory canvas, was it image load or load image? Now I'm not 100% sure there. Let's quickly check. Our in-memory canvas is unfortunately... No, I don't want to print that. Give me the PixelLoop crate, give me the documentation. And where are the features? Okay, there was something like the in-memory canvas in our library, and this one is only available. It is only available if, okay, show me the source code. It's not in this source code. Okay, that's kind of bad design. I should have feature flags. There they are. Okay, it's image load. Okay, perfect. So we need image load because otherwise we don't have an in-memory canvas. That's a little bit of an oversight by me, and I should actually discern the feature set of having an in-memory canvas and having the image loader implementation. However, currently this is a problem, and I will fix this in a newer version. Maybe it is already out when you are seeing this video. Okay, so I guess now we can actually create those canvases, and I guess we somehow need to decode these GIF frames. So let's maybe see what we can do there. Do we have, there was something like into, if I've just seen correctly, into frames. Okay, and this gives us actually a frame. What is a frame actually? A frame is, okay, that's frames is an iterator. Okay, an iterator on what exactly? So iterator for frames, type item result frame. Okay, so we get a frame, and a frame has, oh, perfect. It has the timing information and it returns an image buffer as an RGBA image. Okay, that's actually more or less exactly what we need. Okay, that's a great thing. Okay, so we can do into frames, and does this actually that actually consumes self. So I guess we first need to extract every information that we might need. Something like, do we need the color type? I don't think so. I think we only need the dimension. Do we need anything else? Orientation maybe? Not sure. However, let's get the let's get the width and the height of the decoder dimensions, and then let's get frames. Let's do decoder into frames, and this was it a result or was it the method is available for here animation decoder. So we are missing the animation decoder trait here, and what are we missing here? No method named dimensions? Wait. Dimensions is defined on the decoder, isn't it? It's on the image decoder. We need the trait image decoder then. Okay, perfect. So now we have frames actually. So now we should be able to do something like for frame in frames. Like, can I just, it was an iterator, wasn't it? So I should just be able to iterate that. However, it was an iterator on image result with a frame. So what we actually kind of want to do is we want to do for OK frame in frames. Is this possible actually? With suitable pattern and for loop binding match. Yeah, okay, because we could have an error actually. Can I do something like that? Okay, I can't. So let's just do if or let frame equals frame question mark, so that we actually shortcut out of there. Should this be, or then we can actually do an unwrap. Yeah, we are now just doing an unwrap. We are assuming we can actually retrieve every frame for now. Let's do error handling later on, maybe. Okay, so now we are able to decode the frames, hopefully, and there was something like frame into from parts delay and buffer. We need both of those. So both of those only take a reference and give us a reference. Okay, that's nice. So let's get the delay, which is frame delay. Which format is that actually? What are we returning here? We are returning a delay. Okay, what is this delay? It's a ratio. Oh, it's a ratio. What? Can we actually... ratio. Is there a possibility to deimpl delay? from, can we somehow convert that into something? Trade implementations, clone debug from delay for duration. Perfect. We can save that as a duration. That is actually great. So let's just specify that we want the duration here, and let's do an into here. And let's import the duration, because duration we can easily use later on for our logic there to display this thing. Okay, so now that we have actually the dimensions and we are iterating through the frame, let's get the buffer as well. Frame buffer wasn't it? So now we should have an RGB buffer, and now we would need to iterate this RGB buffer and actually transfer it into an in-memory canvas. So what we actually want here is something like canvas in memory canvas new, I guess, and we need to import this one from PixelLoop, and it takes width and height. Is this actually the same format? Perfect. So we are just creating a new width and height, and we are giving it a new color from RGB A, which is simply 000. Okay, and we need to import the color. This is actually then a PixelLoop color, correct? So from our PixelLoop engine, and we will now have an empty canvas which we can write into. So for y in 0 to height, for x in 0 to width, we are going to iterate our buffer here, which is, I would assume it was just an RGBA image. Okay, so the question is, an RGBA image, can we simply, it's an image buffer, can we simply access that data? Is there a, how do we actually get the pixel data from an, returns the underlying raw buffer? That's kind of what I want, I think. Returns the underlying raw buffer as a container, which then is in term. Okay, so the question is, I want to, or can I say get pixel or something like that? Get, I would be fully fine to just get the underlying raw data. Yeah, I guess we will just retrieve the underlying raw data. So let's go back a couple of references here to our code. Well, there were we. So what we actually want is buffer into raw. And this then does not work, cannot move out of shared reference. Okay, then we do as raw. That's fine for me as well. And now we actually should have a container which then can be dereferenced into the subpixel slice. Okay, so what we now want to do here is actually take our, first of all, calculate the index, which we always usually do, because now we have an array of pixels, like an R pixel byte and a green pixel byte, a blue pixel byte, and an alpha pixel byte. So 4 bytes per pixel. And we have this just in a row in one array, in a one-dimensional data structure. So we need to calculate the index in this array based on our x and y coordinate. And that's actually easy to calculate. You take the current row, so the y, and you multiply it with the width, and then you simply add the x so that you are in the corresponding position. And then we are simply taking this and multiplying it with 4, because we have actually 4 bytes per pixel. And now we are at the starting byte of our current color pixel value. And what we now can do is something like, we should be able to do canvas set x, y, and we give it a color. We do color from RGB. And now we can actually use our index into the buffer, index plus 0, which is the first one. buffer index +1, buffer index +2, and buffer IDX +3. Okay, and this does not work yet because something we will see in a second, I guess. So the problem here is for font in the current scope, and traits can only be used if the traits is in scope. Okay, so I guess I need to import the canvas trait here, and I cannot access that. Okay, it needs a color reference. We can fix that, and now we might have a problem here. Exactly, the type U8 cannot be indexed by a type U32. Yeah, that makes kind of sense. So let's simply convert this whole thing here into a usize. Did we do something wrong there? I added a bracket too much, I guess. And now, what's its problem now? The function takes 3 arguments. Yeah, because I did from RGB, but I wanted to do from RGBA. Okay, so, and now it will tell us that the canvas needs to be mutable. That makes sense as well. So now we should actually have transferred 1 frame into this canvas. So now we should need something to store the canvas. Okay, so let's create something to store an animation frame. So struct animation frame, I guess, and it will have a canvas, which is an in-memory canvas. It will have a delay, which is a duration, and yeah, I guess that's it. And then we need something like, I guess we can create that here. So animation frames equals is a vector here, and let's give it the corresponding animation frame type. Even though it should be able to actually infer that once we add something to it here. So now this should be our, yeah, that's the end there. So now we can do animation frames, push a new animation frame here, which takes our canvas and it takes the delay that we extracted actually. And we need that to make that mutable, of course. That makes sense. Okay, now we actually should have extracted all of the different informations. So after we have done that, let's just for now to test that this works, because we don't have anything to render into yet, output a couple of, a little bit of information. Loaded GIF or GIF, or maybe you can tell me in the comments if it's now called GIF or GIF or how it's called. I would be appreciated. With a couple number of frames and dimensions x by x. Yeah, something like that. And we then have animation frames.len here, and we have width and height here. And now it should actually tell us something if we actually run that. Let's first of all see if we can even build that quickly, or if I have done some blatant error there so that it doesn't even compile. We will see. Okay. Seems to be good until now, but those are only the dependencies. Okay. Yeah, we are not using the information yet. Yeah, that's okay. That's perfectly fine. Okay, so let's do cargo run, and we will run it against our, wait, what? Okay, something in my shell configuration is wrong there. We will run it against, it was center GIF, wasn't it? Okay. That starts in a way that I didn't see coming. Oh, I read in the... Okay. That kind of makes sense. We did something wrong with our argument parsing because we are taking the first... That makes sense. We are taking the... Come on, the first argument here. Yeah. But we should have needed to take the second one, because the first one is actually the called executable. That kind of makes sense. Let's try again. Okay, so now it said loaded GIF with 6 frames and dimension 30 by 30. That actually makes sense. That actually sounds quite reasonable, I guess. And yeah, we will see. So let's go ahead and create something to render this, I guess. So what we need in order to render this are some things regarding PixelLoop. So I guess we can go to our PixelLoop doc here and go to the, where is it? The base crate. I think I had an example there. Yeah, exactly. Let's maybe more or less copy that. And let's put that there. So we definitely need some imports here. So let's put them there. We can clean them up a little bit because some of the inputs we already have. And now let's see. We have now here something like game state. Let's now just call it state. And this is actually the thing that is transferred into our system, which we can access each rendering and update loop. And that is actually something where we, I guess, would hold our animation frames. So this thing would be our vector of animation frame, because that's something that we need in order to render. And I guess we need something like the current frame. So we need to know where we are currently at. So this would be a usize into the vector, I guess. And then we don't need the main function here anymore. And then we are creating actually a cross-term canvas. Let's do this a little bit different, because in this example, we are creating one with a fixed size. Maybe we should create one. We could either create one now with the size of the GIF, or we could create one with the size of our terminal, actually. And I think we should maybe create one with the size of our GIF, because otherwise we would actually crop the GIF. Yeah, maybe we can change this later on. Let's for now just use the width and height of our GIF, which we actually have here. We are setting a refresh limit. Okay, so far so good. We could actually make this a little bit faster. However, I don't think we need to. It doesn't really matter. Then we create the state. We can actually do that. We put our animation frames in there and we say the current frame is 0. So let's do that. Perfect. There is a colon missing. Then we get an input state, which we can then use to run, to check, for example, for the Q key to end all of this thing. That's actually something that we can do here after we have called the PixelLoop run function, which I usually do like this to make it more clear that we are actually calling it within PixelLoop, so we can actually remove that import there. Okay, we are putting our state in, our input, and our output canvas. And this is actually here the output canvas, which is then the cross-term canvas, which renders into the terminal. So now we don't need a way to move boxes or something like that. We can remove those comments, I guess. We only want to check for the Q key, and if it is pressed, we exit the process. Exactly, okay. Now we have the render function there, which we only use to... I don't think we need to clear the screen actually here. I mean, it doesn't make a real difference. However, what we want to do is actually we want to reach into the state. We want to get out the animation frames, or specifically the animation frame, which is the current frame. We want to get the canvas. And I guess we want to use our render canvas and blit the animation canvas into this thing at position 0, 0. And we don't want any kind of tint there. So we want simply copy our specific animation frame right into our animation there. So I guess Where are we currently missing? We don't have the renderable canvas trait. We need that. And otherwise, this looks kind of okay. So we need the keyboard state trait to have the ASCII press thingy here. And yeah. And we might need to import the cross-term state. Arguments to this function are incorrect. Okay, expected U16, found U32. Okay, this kind of makes sense. Our GIF could be larger than any terminal could actually hold. However, it wouldn't make any sense, actually. So let's just clamp that between 0 and U16 max, I guess. Is that not possible? Okay. We need to do something crazy like that and do the same thing here. There might be a better way to do that, actually, what I'm currently doing here. So there might be a better way to just make sure this does not overflow the U16. I guess there are conversion functions which are safe so that you could do that, actually. But this definitely works as well. So the maximum now is the size of a U16, which doesn't even make sense. However, it should be able to compile now. So what's its problem here? Okay, we are returning a result here, so we can actually shortcut out of this if it does not work. So now it should actually go ahead and render at least one frame. It will never advance, but it should render one frame. So let's check if it does, actually. So if I now press enter, we should... Nice! We see our center, even though the colors are off. Are the colors off? I'm not exactly sure if the colors are right here. And we may want to actually clear the console so that it actually looks a little bit nicer when this thing initializes. So let's do a canvas clear screen with a color of black, maybe. Color from RGB 0, 0, 0, and let's remove all that. And now it should actually look a little bit nicer, and some things... Oh, no, that I didn't want to do. Let's just add a reset here, because sometimes we might have otherwise problems with the system there. Why didn't it clear the screen? What did I do? What's its problem there? Wait. So... I'm doing a clear screen. Color from RGB 000 should literally be a black color. Oh, yeah. Okay, our canvas is actually smaller than... Yeah, that makes kind of sense. So we actually don't need that. We have a canvas that is only the size of the GIF. So the moment that I do this, it will actually only use this area. So even though the colors are off, we will take a look at that later on, I guess. It kind of looks like the red and the blue channel are off. Why? Wait a second. What did we do wrong there? Did we do something wrong during copying? So this is the red channel, this should be the green channel, this should be the blue channel, and this should be the alpha channel. So we actually have that from RGB. Red, blue, green. I guess I just found a bug in our... Interesting. I just found a bug in our PixelLoop engine code. So we actually have to flip the the blue and the green channel until I have fixed and released a new version that. Okay, and now it looks okay. So now let's get into animating this thing, which should now be actually reasonably easy. So the only thing that we might need now to do in order to animate this thing is, where is actually our animation function, our update function? Here is our update function. So after doing all this key checking, we should simply be able to do something like state dot, and I usually call this S actually because I have to type it over and over again. No idea why I wrote it out for the example. So we take our state, and however the other things here are now written out as well. So let's call it state. State current frame should be incremented by 1, and if state dot current frame dot is now bigger or equal to state dot animation frames dot len, then we say that the state dot current frame should be 0. Exactly. So now we don't have any timing in there. So this will most likely animate really, really quickly. However, we will fix that in a second. Let's for now, yeah. Let's for now see that we get this working at all, and then we can. It's actually kind of nice. Now let's see that we get the timing. So we actually decoded the delay, and the delay is in animated GIFs. The delay is always the time that a specific frame should be on display. So the time until we should move on to the next. And I guess we need to have some reference now to check against. So I guess what we do is we put into our, where is our state actually? State. Yeah. We put into our state so something like last frame change or something like that. And we simply put an instant in there, I guess. So that we can now do during creation, we simply say last state change is instant now. So we just use the current instant, current timestamp, so to speak. And now we should simply be able to do something like if state dot last frame change dot you can do something like, is it elapsed? Perfect. So if you call on an instant the elapsed function, it gives you the duration since this instant happened in relation to the current time. So that's exactly what we want. So if elapsed is bigger or equal, state dot, maybe it's time for us to extract this frame here. So let's do current, let current equal, what we actually want is just a reference to the current frame, and then we should be able to do something like, first of all, move this to the right position, and then say state, current dot, and we called it delay. So if the duration since the last update is bigger or equal to the delay that the current frame should be displayed, then it is time to go to the next, actually. So this should already do, and then we need to do state last frame change equals instance now. And this actually might already do what we want here and animate correctly now. Okay, now it's. I'm not sure if this. Let me quickly check if this actually is the intended speed there. So, wait, what? GIFs. Let me quickly see. That is very small. However, yeah, that seems to be the intended animation speed as far as I can tell in this really small image. We have a much bigger image now. Let's see, what was this called? I already forgot. So open GIFs. We have exactly snowman. So let's see, snowman. And this will be a lot big. Yeah, this will not work because our terminal is not big enough. So let's make the terminal a lot. No, that was too small. Let's make the terminal, give it a proper size. And there we go. We have wait. Okay, I'm not 100% sure what's actually happening down here. Maybe we have still some sort of a sizing problem. Let's see. Yeah, it was simply not correctly sized. However, ladies and gentlemen, we have invented GIFs or GIFs in the terminal. I love that. By the way, I've just taken those GIFs from Jiffy, I guess. I've just searched for Christmas pixel art or something like that. I will give them proper attribution in the commit, then in the committed code. So what else do we have there? We have some other GIFs there. So let's see. No, we wanted maybe ls GIFs. So we have elf cat. Let's do elf cat. Okay, for this one, I guess we need a bigger terminal again as well. However, that's really cool. So what do we have? We have reindeer, center, snowman, sock. So what is reindeer? Reindeer. Yeah, it's we need a little bit of a bigger terminal for that to actually show nicely. Or we can do sock, and then we will end with my favorite, I guess. Yeah, this one is actually quite cool as well. It's a cat looking out of a sock, of a Santa Claus sock. And now let's make this thing a little bit smaller again, and let's run cat because I love that. I found it initially, and it's okay. I need a really much smaller terminal for that. Let's see. No, that's too small. Let's make it a little bit bigger again. No, that's yeah, nearly. Okay, so that's just awesome. I love that. And the best of all, it's playing within our terminal. It's just rendered using Unicode within our terminal, as you can see in only a couple of lines of Rust code, and that's just awesome. And yeah, I hope you had fun seeing me code and enjoying me coding this a little bit festive PixelLoop thingy here, which simply loads and shows animated GIFs in the terminal. And yeah, I hope you had fun as much as I did. And if you did so, please give the video a thumbs up. Hit the bell and the subscribe button, and yeah, you may leave me a comment. I always welcome comments. It definitely helps with the YouTube algorithm if a video shows more engagement. So please leave me a comment if you like that. If you have any questions, ask them. I will try to always answer them. And yeah, maybe tell me if it's now GIF or GIF, because I don't really know. And yeah, I hope to see you in the next one, and I wish you a very wonderful Christmas time. So see you again. Bye.